All right, so welcome to the second video in this module about dimensional analysis. So in the last video, we covered very basics of units. And this one, we're going to cover thinking about units as variables within algebra. And specifically, we're going to cover thinking about units in terms of addition and subtraction within algebra, and also as multiplication and division within algebra. Switch to this. All right. So the first example I'll do, we'll just do a basic overview of variables within adding in algebra. So right, when we had stuff like when we had expressions like if I gave you 6x plus 6x, you could tell me that that could simplify to 12x, right? Because these both had the same variables, they both just had x, so I can add them together and I could just get 12x. But if I give you something like, 6x plus 6y, I can't simplify that because this has the units or the variable x, and this has the units or variable y, right? So if we think about just transforming these variables into units, which essentially act as the same thing. So if I give you something like, if I say something is 6 degrees Celsius, and that it gets 6 degrees Celsius hotter, right? These both have units of degrees Celsius. So I can actually add them up and get 12 degrees Celsius. But if I told you something was 6 degrees Celsius and it grew 6 meters, right? So where degrees Celsius is a unit measuring temperature and meters is a unit measuring length, these aren't the same thing, right? So I can't actually simplify this to anything else. And this really mirrors the earlier situation with 6x plus 6y, right? If I don't have the same units, right, in this case x and y, I can't simplify them any further. But if I do have the same units, like in this case up here with x and x, I can simplify it. So the next one we'll think about, so this one will be a little bit more lengthy, is thinking about it in terms of multiplication and division of units. And it's a little bit different than earlier. So remember from your algebra days, when you would multiply two binomials together, you might think of it more of when you did the FOIL thing, right? So first, outer, inner, last. Okay, we'll do an example. So if I have 3x plus 2 times 2x plus 4, right? Super quick math because I'm just so good at this. I can do it off the top of my head. 6x squared plus 16x plus 8. Definitely didn't do this ahead of time. Okay, so let's think about this as variables, right? And we'll go through this term by term. So, right, so first part of FOIL is I multiply the first term, so in this case 3x and 2x. So multiplying 3x times 2x, and I get 6x squared. Okay, so two parts with this. Right, so we get 6 just by multiplying 3 and 2. Okay, but then this x squared, right? That's because, so we came in with something with the variable x and another thing with the variable x. And by multiplying them, we actually multiplied the variables by each other to get x squared, right? So keep that in mind. Keep that in mind for later when we talk about units. Okay, the next term is 16x, right? So 16x came from the outer and the inner part of FOIL. So that is the number 2 times 2x plus 3x times 4. All right, so that, take it step by step, gets to 4x plus 12x, which gives me 16x. Okay, so yeah, once again, just think about this, right? So I had the number 2 times 2, so that gives me 4. But notice here, when I have this first 2, there's no variable with it. So it essentially has no variable. But when I multiply by something with the variable x, I end up getting, right, the variable x as the product. Same with this part right here. So 4 had no variable, but 3x did. And when I multiplied them, I just got x. So we can think about it from earlier, right? When we multiplied x times x, we got x squared. And here we multiply no x times x, and we just get x. So you can start seeing now that when you do multiplication, you actually are just multiplying the variables you have to get the product variable. And it's the same exact thing once you get into doing it for units. And the last number is not too important, right? So 8, we had no variable for 4 and no variable for 2, and we got something that had no variable at the end. So, okay, now that I've done this very vague algebraic just example, we'll do an example grounded more in towards something you would see at school. But hopefully from this, you took away that when I multiply these things, I'm not just multiplying the number, I'm also multiplying the thing after it, right? So the variable or also the unit I'm multiplying. So an example grounded in physics, a lot of times you'll see something where they'll ask you to calculate the kinetic energy of things, right? So the equation for kinetic energy is 1/2 times mass times the velocity squared. Okay, so let's say that you have this cool new car and it has a velocity of, let's say, 30 meters a second. And let's say that its mass is 25 kilograms. Okay, so what's the kinetic energy of this? So we'll set it up. 1/2. Our mass was 25 kilograms. And then our velocity was 30. And remember from the last video, we put meters up top per 1 second squared. Okay, to jump a lot of steps, this is 11,250 kilogram meters squared per second squared, which is also the same as 11,250 joules. And don't worry about this joules thing if you don't know it yet. Okay, so lots of things to unpack here. So it's the first one, we'll talk about this whole squaring situation, right? So the units we went into were meters over second. And when we squared that, remember that squaring is essentially just multiplying the term by itself. So it's meters over second times meters over second. Right, and then just like if we have algebraic units and we have x times x over y times y, we're gonna get x squared over y squared, same exact thing in this situation, right? So we get meters squared over seconds squared, which is what this part of the unit was, right? Okay, so anytime that I have a unit, so let's say some unit x raised to the power n, my product units will always just be x to the n, right? So if I have meters raised to the second power, I get meters squared. If I have a way more complicated thing like a joule per second squared, my units are joule squared over second squared. So that's true all the time. All right, so just clear things up a little bit. Get rid of some of this. Gotta make sure I keep my very good car drawing. Okay, so next, I multiplied 25 kilogram, multiplied that by what essentially this simplifies out to is 900 meters squared over second squared. And then, so notice my product, right? My units, my product were kilogram times meter squared in the numerator, and then over second squared. So just like in algebra, if we think of this as like 25x, and this is like 900y squared over z squared, my product is actually just going to be the multiplication of all of these units together, right? So that's why I got 11,250 kilogram meters squared per second squared. Or if I did it in terms of these variables I just gave you, it would be xy squared over z squared. So you just multiply all these units together, and that's the unit of your answer. Sometimes combinations of units are so common that they just get a new definition. So kilogram meter squared per second squared is so prevalent within physics that it has a different name that's called a joule, which is abbreviated by J. And we'll talk more about that in the next video because we're going to cover SI units in that. So let's go over one more example. So let's say that you're going 30 meters per second, and you want to know how long it takes you to travel 10 meters, right? Okay, so from kinematic equations, I know that there's an equation that says time equals distance over velocity. Okay, so I traveled 10 meters, right? So that's up here. And my velocity, remember velocity has to be in units of some length of distance over a length of time. So meters over second, that's that. 30 meters over seconds. Okay, so fractions, everyone's worst nightmare. If I simplify out these fractions, right, so if I'm dividing by something that has a fraction, I could change that so I could say that's 10 meters times the unit seconds divided by 30 meters. Okay, so this is the great thing about multiplying and dividing by units is that they can cancel out. So if I have meters on the denominator and meters on the numerator, and they have the same power, right, is both to the power 1, I can just cancel them out. So they're gone. So now this simplifies that to 10 seconds over 30, which is just 1/3 of a second. So this shows that units not only add together when you multiply, but they can also cancel out when you divide. And kind of remember that multiplication and division are really just two ways to describe the same exact thing. So division and multiplication will result in either you getting brand new units, so that's new combinations of units, like when we had kilogram meters squared per second squared, or if you multiply and divide, you can end up just getting rid of the units you had. So those are the two combinations that you'll have. So just as a summary, when you add or subtract, you would keep your units always, right? Okay, so, and then let's say multiply and divide. You either get brand new units, or you cancel out units you had. So these are the overall outcomes you'd get from pretty much any problem you'll ever do. So just remember, if you ever see units and they start confusing you, just sort of start thinking of them as variables, like back in algebra, right? So if you don't know what meter is, let's just pretend it's the variable x, right? A lot of times that sort of simplifies problems down if you have just really crazy units. All right, so hopefully this video helped you. In the next video, we're going to go over what SI units are and why they actually matter.